All right, so to go off of a little bit farther of our looking at functions and deciding whether or not relationships were functions, then we looked at identifying the domain and range of those functions. And today we're just going to decide if they're linear or nonlinear functions. So when we're identifying a linear function is anything that makes a straight line when we graph it. The only special condition is that it can't be a vertical line. Cannot be vertical. And remember, vertical is up and down. So when we're looking for a linear function or deciding if something's linear, we just want a graph that's a straight line, but it can't be a line that goes up and down. It has to be either diagonal or side to side. Another way we can decide if something's linear is if it goes up by the same amount each time. So we could say the rate of change is the same for each point. Or last year you probably called it the slope. The slope has to be the same every single time, so we have to increase or decrease by the same amount from each point. Nonlinear is going to be any graph that is not a line, and it's going to have rates that change by all different numbers. So it could go up by 2 and then go up by 3 and then go down by 1. It's not going to be the same. So the rate of change will vary. So your classwork today and your homework is just going to ask you to look at either graphs or tables or equations and decide if they're linear or nonlinear. So the first thing that we can look at is is a graph. So a graph, if I ask you to determine if a graph is linear or nonlinear, if I look at that first one, it makes a curve, right? It's not a straight line, so that means that this is nonlinear. Because it's a curve. So you're literally just looking at the picture if it's a graph and deciding if it's a straight line or not. The second one, even though it's a diagonal line, it is straight. It looks like something I could draw with a ruler. So the second one would be considered linear. So with a graph, it's pretty straightforward. Either it's a straight line or it's not a straight line. I could also give you a table, And if I'm giving you something that looks like a table, it's going to be a little bit more work because we have to check and make sure that it's going up or down by the same amount each time. So if I look at that first example where I have my x values are 3, 6, 9, and 12, and my y values are 36, 30, 24, and 18, the way that I like to check or make sure that I'm doing the problem correctly and showing my work is I like to go in and I kind of just draw arrows and decide, okay, from 3 to 6, in order to get from 3 to 6, I have to add 3. To get from 6 to 9, I'm going to add 3 again. To get from 9 to 12, I have to add 3. So because all of those numbers match, I'm off to a good start. They all have to be the same in order for it to be linear. So now I need to check and make sure that my y values are changing by the same amount too. So then I'm going to say, okay, to get from 36 to 30, I'm going to subtract 6. Now, even though that's different than the plus 3, that doesn't matter. My x and my y don't have to do the same thing. Just all my x's have to increase or decrease by the same, and all my y's have to increase or decrease by the same. So I'm going to
Mrs. Silva.
Yes.
Will the recording of the notes be on Google Classroom?
Yes, it will.
All right, thank you.
You're welcome. So then, if I go from 30 to 24, I'm subtracting 6 again. And from 24 to 18, I'm subtracting 6 again. So because all of my x values are increasing by 3 and all of my y values are decreasing by 6, I can say that this is linear. Because my x values change by the same amount and my y values change by the same amount.
I have a question.
Yes.
Say like only the x's do the same thing and the y's don't. Is it going to be linear still or no?
No. So then it wouldn't be linear. That's a great question.
So they both like equal.
Exactly. They both have to be doing the same thing. So this is linear because x and y are changing by the same amount. So they don't have to, the x's and the y's don't both have to change by the same amount, but all the x's have to change by the same amount and all the y's have to change by the same amount. So it's okay that I have a plus 3 on the top and a minus 6 on the bottom. All I care about is that all of the top is plus 3 and all of the bottom is minus 6. So then if I look at example number 4, I end up having from 1 to 3, I'm adding 2. To get from 3 to 5, I'm adding 2. And to get from 5 to 7, I'm adding 2. So this is looking like it's linear, but if I had just said it was linear without continuing on to check the bottom, I would have been wrong, because to get from 2 to 9, I'm adding 7. But to get from 9 to 20, I'm adding 11. And to get from 20 to 35, I'm adding 15. So because my y's are changing by all different numbers, this is not a function, or not a linear function. So non-linear because y values are changing by different amounts. Another way they can try to trick you with this is sometimes they might make it be like multiples of 4, where it would be something like 4, 8, 16, 64, and things where we're multiplying. So we have to always make sure that you're only adding or subtracting the number. You can't multiply or divide. You have to only add or subtract. So if you saw that the pattern was like times by 2 or divide by 4 each time, that's not going to be linear because you're not adding or subtracting a number. You can only add or subtract numbers to figure out your pattern. Do you want to see another example of those, or how do you feel about that? Good? Okay. So then the last thing that I can ask you is to just look at an equation and decide if it was linear or nonlinear. Are you okay with me changing the slide? You've got it written down? Okay. So if I gave you an equation, now when I go and look at all these different equations, in order to decide if it's going to be linear, a linear equation is going to be something that looks like y equals mx plus b, where m and b are going to be numbers, and I have a y in my equation, and I only have an x. So the most important thing that I'm noticing with linear equations is that the x only can be multiplied by a number. The x can't have an exponent, it can't be dividing things, it can't have square roots. It has to just be multiplying by a number. So can only multiply. It can't have exponents. It can't be an exponent. It can't be in a denominator, which is our bottom of our fraction. So we're looking for things that are going to make just straight lines. So if I look at this first example, y equals 3.8. Right off the bat, I notice it doesn't have an x, but it does have a y. So I'm not really sure if this is linear or not linear because it doesn't look exactly like my y equals mx plus b. But if I think about it a little bit, I could rewrite a to be y equals 0x plus 3.8. So I can make it look like my y equals mx plus b. So because I can make it look like that, that makes it a linear function. So even though it kind of looks a little wacky because it doesn't have an x in it, you can just have that plain y equals a number, and that is considered linear because it's just saying that our change is 0, which is going to be 0 every single time. So that's okay. So this would be, A would be considered linear. When I look at B, B says y equals the square root of x. Right away, I know that's not linear because I can't have a square root of x. I can't have anything happening to the x except for multiplying by a number. So this is nonlinear. When I look at C, my x is the exponent, and I know that that's not allowed, so this is nonlinear. When I look at D, where I have y equals 2 over x, x is my denominator, and that's not okay, so this is nonlinear. When I look at E, I have y equals 6 times x minus 1, which doesn't look exactly like my y equals mx plus b, but when I take the 6, I could distribute it in, and I could make it look like y equals 6x minus 6, which now this does look like my y equals mx plus b. So this one is linear. The last one, the f where x squared minus y equals 0, because I have an x that's squared, it has an exponent, this is going to be non-linear. So anytime something's happening to the x besides multiplying it by a number, that's not going to be a linear function. So in your classwork today, you're going to have to look at graphs, decide if the graph is a linear function. You're going to look at tables and decide if they're linear functions, and then you're also going to look at equations like this and decide if they're linear functions.